Okay, dear students, let us see what is there in this question. A third harmonic standing wave of wavelength zero point 0.8 meter is set up on a string fixed at both ends. Okay, so the string is fixed at both ends and the wavelength is already given. It's third harmonic they're talking about. 2 points on the wave are separated by a distance of zero point 0.6 meter. What is the possible phase difference between the 2 points on a wave? Okay, so my dear students, first of all, I would like to again specify this property of standing wave. What is it? That the 2 points on a standing wave, either they are having zero phase difference or they have a pi phase difference. Like one thing is clear, like there is no scope of this pi by 4 or pi by 2. Whenever they're talking about a standing wave and they're talking about phase difference, this and you see here even D is wrong and the answer is C. So we have now answered it within 1 minute that the answer will be pi, because there are only two options in the standing wave. Like if it is a standing wave, either the phase difference is equal to 0 or it is pi, and 0 is not here in the option, so definitely the answer is C, that is pi. Now let me explain you what the hell is actually happening here. You see, 0 is the phase difference between the 2 points which are belonging to the same segment. Like this. Okay, and let us say this is the node and this becomes the other thing. Now you see, so let us say I'm talking about this point P and this point Q. So you see P point is going up, so Q is coming down. Like this is the standing wave I have drawn. Do not please confuse it with the traveling wave. No, no, no. This is standing wave. So you see when P is moving up, Q is going down. So it means that the two particles which are belonging in two different segments, they are always moving in the opposite direction. And the phase difference between the 2 points will be pi. So the answer is pi. We will see whether the answer is pi or not, because the wavelength is given uh, and this is zero point 0.6. So you see the wavelength, this is one wavelength if we are taking this particular example. So this is one wavelength and the wavelength is zero point 0.8. So this is the midpoint, which is 0.4 meters away. And the distance given is 0.6 meter. How is this possible? It is possible only if the 2 points are lying in the two segments, two different segments. They cannot be within one segment, because the length of one segment, it comes out to be equal to 0.4 meter, isn't it? Lambda by 2. Wavelength is 0.8. So this is 0.4. But the distance between the 2 points is 0.6. It means you are indeed talking about two particles which are in the two different segments. And that is why we come to this conclusion that yes, the phase difference will be pi. And let us say if there is another point here, I named it at R. Now both of these 2 points, like P and R, they belong to the same segment. So both of them have the zero displacement at the same time. They go up at the same time, although they have the different amplitudes, but they reach the amplitude at the same time. They come back at the same time and they go below at the same time. So they are always in the phase. And so the phase difference between P and R is 0. So in this case, the answer will be 0. And in the case of P and Q, the answer will be pi. And that is why the answer is C. Let us verify from the mark scheme also. And yes, the answer is C. So this is how we do this question, my dear students. This is Professor Varun. Please subscribe to the YouTube channel. All the best.